So in this video, we're just going to take a quick look at GeoJSON just so that we start to get the overall feeling of how things are structured in there. So I have this, or I had, this is one of the layers that I dumped in the GeoJSON. We'll take a look at a couple and then give you sort of a gotcha with the leaflet library and that. So first, there's this concept of feature collection and that give it a name. It's almost like the layer name. Type is kind of self-described. When you go to type, it says, hey, I'm a feature collection. So if you ever like just bump into an object in JavaScript, if they do use this technique and they do here, you can always say, well, what are you? And when you ask the object, and the object says, hey, I'm a feature collection in that. So there's four big things: name, layer name, type, self-describing, like string that says, yeah, I'm a feature collection. CRS, that's like your SRID, that's your coordinate system, and then features. Features is, as you can see down below, it is an array of feature, and then, right, so features is almost like, how can we say it? I mean, the whole feature collection feature thing is like a feature collection is like a layer. Features is like the table for the layer, so it's all the rows, right? And each feature is a row. Now the feature will type will say, hey, I'm a feature. It'll have geometry. If you ask the geometry type, well, that's going to depend. Am I point line or polygon? And then there's going to be a list of coordinates, which is also an array in that. And then properties, which is kind of, honestly is an object, and it's a key value pair of properties for a particular feature. But that's how we would like move from the geo-relational model, like rows and columns. Those would be like the column names typically if you just like dump the data from a shapefile or a traditional GIS layer, whether it's coming from GeoPackage, PostGIS, or something. The properties are like those column names and that. So let's just take a look. Should we take a look at the one? Schools? That's catchments. That's different. Neighborhood. Yes, this would have been one of my original ones that gave me some trouble and that sort of thing. So outside here, you don't know what it is, so it has a little bit of like a descriptor. Hey, I'm a feature collection. Name is kind of like, would have been the layer name that you gave it in whatever format, shapefile, that would have been the name of the file. Could have been a layer GeoPackage. So what did you call the layer? Like in a product like QGIS, just before you exported it, it gets tagged with that. CRS, I think I cleaned this up because I was having some issues. Hey, why isn't the data showing up? So European Petroleum Survey Group 3857, WebMacator, okay, and that. And then you get your array of features. So that's like when you right-click Open Attribute Table in ArcPro or right-click Open Table in QGIS. This is kind of like the table concept. The one thing is this is we're moving from a highly noted document store, like a NoSQL document store, off of a geo-relational one, right? So traditionally, GIS layers are two-dimensional tables with, where every feature or piece of geometry on the screen is a row and a table, and the columns are, the column names are stated once at the top of the table, and you just assume that that is the column name throughout, all the way throughout. And that you'll notice here that the column names get punched in a whole bunch of time for each feature because of the way it's structured in that. But features is an array, so this would be one feature in the array, right? And so it's fid. Feature ID is 1, its name is city center, the number of schools is 8. These are properties. And then it lists its geometry. What type are you? I'm a multi-polygon. And here's the array of coordinates. Now this is like these rings. Because it's multi-polygon, the first encloses all the polygons that can make it up. And because a multi-polygon, I guess you had to separate each polygon from itself. And this would be this would be the ring of the polygon technically, and then this would enclose the X, Y, maybe Z values in that. The big thing here to look at is, wow, what are those coordinates, right? They're big, right? That's WebMacator, and that's WebMacator for our part of the world in BC, and that. And so I think it's like 20, it's minus 20 million to positive 20 million, roughly, for the whole globe. And so we're down in this area here, and this would be one vertice, X, Y, X, Y, X, Y. And then we get all of these, and that would make up, Just pick this one here. This would be the magic one here. All of these these are all the vertices for one polygon. Now none of my polygons in the holes. No, I think I have one that has a hole. Wally has a hole, so you might notice something different on that one if you were to slowly go through this. But then this is the next row, the next feature. Its feature ID is 2. Its name is Newton. Number of schools in there are 53. And again, these are all WebMecator coordinates, just so you know. I'm going to flip over to catchments is one I did before, right? And so again, that would have been the name of the layer when I was in QGIS before I dumped it as GeoJSON, right? Self-describing type thing here. Hey, right? Because if you just encounter this little brace, you don't know who you're talking to. Hey, what's your type? Hey, I'm a feature collection. Here's my CRS. Ooh, European Petroleum Survey Group 26910. It's UTM Zone 10. Okay, so there's a little bit of an SRID thing going on here, and this can help out in other libraries, but it depends. A lot of the web mapping libraries might need the addition of Proj 4. I mean, some have version 8, but that's what most people call it. The Proj 4 library, everyone kind of identifies as the open source library that a lot of products use to transform out of one projection into the other. That's why you need the SRID data to know, well, how do I do that? So these coordinates look very different. These definitely look like northern easting. They're all positive. Could be melt bell bears, but the numbers are a little bit bigger, melt bell bears. Like I said, they are all positive. That's how northern and easting work for that particular projection in the area that we're in. That's about the right range. And again, the same structure, right? Feature, polygon, coordinates, 1, 2, 3. This is polygon, so it's just 2 rings, right? So this is the ring. This is the thing that encloses all of the rings. This is one particular ring. That's kind of interesting. Yes, yes, yes. Right. So if you went back to the other file, you would see like 3 in a row. 3 opening square brackets in a row. Because a multi-polygon can have disjoint rings, like the Hawaii island chain is just the whole thing is the state of Hawaii, and that. But those are definitely UTM coordinates. And we can scroll down for a while, and we get to the next one, right? And that the catchments, they can be dense in terms of vertices in that. Here and here are all the properties, right? School catchment type, it's a secondary school, name of the school, all that kind of stuff, creation, modification date, and all that. Now, out of the box, Leaf isn't going to be able to display any of this data, just so you know. So we need one of these over here. Okay. I'll give it a second so it colorizes everything, not to confuse it. Again, self-describing object, because you just bump into the curly brace, you know it's an object, but you don't know what type. So it says, hey, I'm a feature collection. And that name the layer when it was in QGIS, basically, CRS. This is how it really dumps out the CRS, right? So I was thinking, hey, maybe this formatting is throwing it off, that sort of thing. But that wasn't it in the end. And this is describing sphere too. CRS 84 would be what we would call it WGS 84, which is 4326 in terms of projection. And so we'll see the issue once we get down here. Here's like the rows, all the features for the feature collection, and that start here. Hey, self-describing object, right? What kind of object are you? Hey, I'm a feature, right? Here are my properties: fid, layer. It is called layer, but it would have been the name of the neighborhood at the time. In that, here's your geometry multi-polygon, because it's multi-polygon, right? 1, 2, 3. So this would be all the polygons that make up the multi-polygon. This is for one individual polygon, all the rings that make up the polygon in case you punch a hole out. And this would be the XY groupings. And notice these are lat longs. These will slide into leaflet really easily. It's kind of expecting everything to be in. This is long lat format. I should tell the truth, right? So that is the X and this is the Y. But it was expecting those coordinates in that. You'll notice in the leaflet library, a lot of stuff is, yeah, it's lat long, so it's YX in that. But in terms of GeoJSON, it's an XY system, but it is expecting lat longs in that. And this would be the, where would be the next, the next feature. right? Newton in that. So you might, do we dare find Wally? Control is, there's Wally. You might notice that there are a couple of rings in here. I did have to punch out a hole in that to fit in City Center, because City Center is within Wally. I don't know if that'll show up in the rings here or not. Oh, there we are. Boom, boom, boom. There's the hole getting punched out at that point there. A little bit of a geometry freak, so I apologize in that. But yeah, these are how it's an array of features, or each object, it's an array of objects too. All right, and that this would be the separator between the two features. In that, this is a new feature starting. It's got a new name, South Surrey, number of schools, in that in lat long format. That keeps the system happy. But it's just to give you a feel for how GeoJSON is organized in terms of a data set. Now, like I said, the coordinates, right, don't have to be lat long. But if you ever get into that thing where you have the blank map and you're like, trying to figure out like what's going on, why is the map blank? Don't be surprised if it's a coordinate issue. And every mapping client's different, right? The SRI mapping client, the first layer loaded gets to set what the SRID is for the map, and if all the other ones are in the same SRID, it's usually fine. Open layers kind of behaves a little bit the same. It all depends. A lot of times if you need to project or transform on the fly, you definitely need to bring in some help in that. I think, yeah, raw web Mercator coordinates doesn't throw off open layers, but UTM might in that. So every web mapping client's a little different. These are some idiosyncrasies, some nuances that you discover along the way. So I think that gives us a good idea of the GeoJSON format, made you aware of the gotcha for leaflet, and we'll wrap it there. That's all for now.